section. So I suppose we can just start at the very beginning.
Yeah.
We can just share our information for question 7.
Yeah.
Yeah, I didn't finish question 7, but I know how to do it, if that makes sense. But let's go ahead and start on that. I just didn't have enough time.
All right, well, I used the random number generator just to get to the 3 numbers. My numbers are 3, 7, 21, 18, and 17. Calculated the mean with the salaries, and my mean was 47,500. And on the mark, I just marked it. You know,
Yeah.
that third one between 46,000 and 48,000, which is 47,500. And part C, I said it's usual because it's near the actual mean of the population, and the population's a normal. Normal, whatever. So that's my answer.
Mine came out. I was like, I didn't write down the numbers I did, but my mean of whatever numbers I did came out to be 47, 320. And yeah, I just marked it on the graph. And I said yes, because same deal, is pretty close to the mean of all of them.
Yeah.
But they did like the law of large numbers, the more you do, the closer you'll get to the mean.
Yeah. Yeah. Got a thumbs up. Let's see. So I mean, there's I don't know. There's only 3 of us, so I suppose that counts for that. And for 8A, I said it was approximately normal. In the answer key, it says it's actually normal, but same thing. Same thing. I just closed the answer key. I had a question with that. And it's normal because the data is drawn from a normal population. And the mean is 529. And then my question is with the answer key.
Yeah.
I just accidentally closed. Let me open that up again. For the standard deviation of the distribution of sample means scores for all such samples, I got, let me see, answer key. We're in lesson 6, right?
36. So you said?
So we're in lesson 6, aren't we?
Yeah. Yeah.
We are in lesson
6.
I need to sorry, I just woke up. I should have. I don't know. I was trying to be so proactive in doing this 5 days ago, because now I can't remember any of it.
Yeah. Well, I'll just download the answer key again because I can't find it in my downloads. So my question is, I did the calculation that's in the reading. That was the standard deviation divided by the square root of a number of samples. And that got me 3.162 approximately, because I rounded to the nearest third decimal. But in the answer key, it says the standard deviation is 35.734, which I don't know where he got that. Based on all the reading, the videos, I didn't see anything that said that gave me any information that would lead me to getting that number.
Okay, let me bring up my spreadsheet. I'll try to get my spreadsheet. Yeah, because it's maybe 113 divided by the square root of the n 10. So what's that divided by that? I got 35.77. I got 35.73.
Okay, let me try this in Excel because maybe my calculator wasn't doing it.
Maybe if you used a hand calculator, just something got weird and
yeah,
give you the right.
Yeah.
Let me do it in Excel then, because
Yeah, this is what I got for the square root of 10 there.
let me pull up.
And that was what I divided it. So that was the answer, right? 3734.
Okay, so I got this 3.162 part. What did you do from there?
And then I divided 113 divided by the square root of 10.
Oh, so it looks like my calculator was just calculating the square root of 10. Why wasn't it calculating the? That's weird. Okay.
Okay, cool beans. Oh.
Okay, I'll get in.
Oh, I meant to hit stop. There we go. Alrighty, so there we are. That's all. Do part 2. So you guys good to go into the quiz?
Yeah, let's get this quiz done.
Yeah, there we are.
Here. Oh, there we go. Sorry, I should have had it open.
All right.
There's an error processing my request. Let's refresh that, see if that works. All right. Okay. So when you're taking the sample size N5, what is the shape of the distribution? It means
Well, it'd be skewed right. Yeah, it follows
when
the
the parents is right skewed, yeah. Because yeah, you're right. Because it follows the same.
It'd be skewed right. Yeah.
Yeah. The sample size when taking N in the distribution means of the histogram and the parents is right skewed. Wasn't this like the
let's see, law of large numbers stuff here.
yeah, like the larger you get, the closer it'll be to being normal.
Yeah.
You'd still put normal on that one.
So I think it'd be normal.
Yep. All right, number 5. When you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is normally distributed? It's normal.
Yeah, it's normal.
Oh, hard.
Normal, right?
Yeah, normal. Number 6, when you're taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent's population is normal? It's normal.
So I put choose.
When would the distribution means be normally distributed? I'll choose all the correct answers.
The mean sample mean is.
Okay.
So we were going to do, so here.
This next multi-select is essentially answering the previous 3 questions we answered.
Yeah, so it's normal no matter what if the sample size or if the population is normal. And then it's normal if the sample size is large and it's skewed. Correct?
Sorry. Sorry, what ones did you say again? So the data is.
So whenever the population is normally distributed, it's always going to be normal, right?
Yeah. Whether it's a small size or large size.
Yeah, whether it's small or large sample. However, when it's skewed, the population is only normal when it's a large sample size, correct?
Yeah, the only one we don't select is when it's skewed right and the sample size is small.
Okay.
And the sample size is large?
It's normal when the sample size is large, so we don't select it when the sample size is small and is skewed.
Oh.
Because it's a big enough sample size that it doesn't matter if.
Yeah, so the one that on mine it says, so wouldn't it be the data drawn from the population that is right skewed and the spot or the sample size is small. Wouldn't the sample size be small to make it skewed? Because once it gets bigger, it starts to be normally distributed.
These are the three that I selected. It's asking when would the distribution of means be normally distributed?
Yeah, I know. That's what I'm saying. But I'm saying I don't think D is right, because D is data drawn from a population that is right. Oh, it's asking when they're normal. Dang it, I'm sorry, I'm an idiot.
No, you're fine,
I was like, all right, disregard that. I'm sorry. Should read the question a little bit better before I start trying to explain myself. All right. Central limit theorem.
Which of the following gives the best explanation of the central limit theorem? If the parent population from which the data are drawn is normally distributed, then the sample mean, x bar or whatever, will follow a normal distribution. No. Okay, for bell-shaped data, approximately 68%. That's not it. Probably one of the last. If the sample size is large, the sample mean x bar will be close to the population mean. If the sample size is large, stable, the distribution of the sample means will be approximately normal. I feel like it's not the bell-shaped where it has the 68, 95, 97, because that's a 68, 95, 97 rule.
Yeah.
It's different.
There we go. Got it. So
which one? I'm sorry. I was.
Question 8.
So in the book, it says you observed in a simulation that the sample size is large. The random variable x will be approximately normally distributed. So if the sample size is large, then so it's D. If the sample size is large, the shape of the distribution shape will, or sample of means will be approximately normal.
Okay.
Okay, yeah, that's what I was thinking.
Okay.
Based on the reading.
Cool.
Use following information to answer next 4. Let x be a random variable with a population mean of 10 and the population standard deviation of 6. Suppose a sample size of 36 is drawn from this population. What is the mean of the distribution of sample means?
Just U, right? 10.
Yeah, should be.
Number right there.
And then the standard deviation is this. It's the same thing we did with that spreadsheet.
So it should be 1.
So it's 36.
36.
Divided by the square root of 36, 6, right?
I thought you did the square.
Yeah, I got 1.
Oh, no, you're right. So 10 square root of 6. Then 10.
Got 1 for that?
Or 1? That's what I meant, yeah.
Yeah, okay. Just want to make sure, regardless.
Wait, sorry. We do, so, sorry, that one, it's the standard deviation. I'm dividing it by the mean instead of the standard deviation. So, not bad.
You're fine.
You're good.
Okay. Regardless of the distribution of the population, the sample size is large, greater than 30. What would the shape be?
Be normal?
Normal.
It's so redundant, these questions, really. I have no problem with them. It's just, yeah. What theorem would justify your response to the last question?
The central theorem, right?
Central limit theorem, yeah. Because the law of large numbers talks more about not the shape so much as the size of the standard deviation.
Well, yeah, sorry.
It says a law of large numbers states that if a sample size is large, then the sample mean will typically be close to the population mean. This happens. Yeah, I think it's a central.
Just the last question. Yeah, you're right. I'm sorry.
Central limit theorem. Yeah.
All right. Has one of you submitted already?
I'll do it.
Okay.
We got 100.
Cool beans. All right. Well,
Too bad Edwin didn't make it today.
Yeah.
I sent him a reminder email last night. I mean, I don't know what the I don't know what the time, or whatever time zone he lives in, but sent him on 6 hours ago, and then one this morning. So
It should be afternoon for him, so he's definitely not sleeping right now.
Yeah. So you would have sent the email like 10 o'clock yesterday for him.
yeah.
10 o'clock in the morning.
All right. Well.
So, don't know.
Yeah. And then, oh, that wasn't. I'm not thinking for this class. All right. Well, cool. I'll post this video and see you guys on Wednesday.
Sounds good.
Yeah.
Cool,
Thanks
man.
for sending out the link. Thanks for posting it too. Appreciate it.
Yeah, man.
I got you. It's not real hard. So.
All right.
Cool beans, guys. Have a good one.
Bye.